Hello, everyone. All right, so in this lesson, we're going to talk about solving systems of equations by elimination. So just to kind of start off and give you a general idea, we want to be able to add just these two values. So 25 plus 178. So in order to add these values, we want to vertically align the place values. So I'm going to do 178 and 25. I promise this is relevant. So what I'm trying to ensure I'm doing is I want to make sure the ones places are vertically aligned. I want to make sure the tens places are vertically aligned. And I want to make sure the hundreds places are vertically aligned. So I just want to be very strategic in how I align everything and how everything gets set up. So when I add 8 plus 5, I'm looking at just the ones places. Gives you 13, carry the 1. So 1 plus 7 gives you 8, plus 2 gives you 10, so 0, carry the 1, which gives you 203. So really the alignment is what we're really looking at. So for elimination, we have to be very strategic in how we set up the problems. So we have to write both of our equations in standard form. So ax plus by equals c. And we want to ensure that variables are in alignment. That's the important part here. So we're essentially going to be adding the two equations to eliminate one of the variables that has inverse operations. So what we're looking for are zero pairs. So just for example, let's say I have 3. For a zero pair, we're looking for the inverse of it. So the zero pair would be -3. So if I add those together, those would be 0. Now if I do like -5, the zero pair for this one would be +5. So if I add those together, I get 0. We're always looking for the inverse to make a zero pair. So for example, if I have -4, the opposite would be +4. If I give you 3/4, well, it would be -3/4. So regardless of what the number is, we're looking for the counterpart to make it a zero pair. All right. So we're going to kind of use that justification and idea just to kind of go through this first one. So looking at your setup here, your system, we want to first ensure that it's in standard form. So we have our ax plus by equals c, ax plus by equals c. So both of these equations are in standard form. So I want to check the vertical alignment. So I want to see, do my x values line up? Well, they both do. Now I want to check to see my y values. Well, both my y values are here. And last but not least, my c values. So everything is vertically aligning. Now, what you want to be looking at are the coefficients. So when I say coefficient, we're looking at the number in front of the variables. And what we're looking for is a zero pair. So if you notice, 6 and -3, those are not inverses of each other, so those would not eliminate. But if I look here, we have -4 and +4. Those numbers are zero pairs. Those are inverses. So what that tells me is when I add these two equations together, that means those y values would eliminate. That's the whole idea of this method, is we want one of those variables to eliminate. So I'm going to add 6x and -3x, so 6 plus -3, which gives you +3x. And then I have a -4 plus 4, and that results in 0y. So that is our zero pair. That's what zeroed out. And now I have 14 plus 1, which gives me 15. So I want to take this equation and I'm going to rewrite it below. However, anything times 0 here is 0. So that term, the y value, is gone. So all I have left here is 3x equals 15. So now I can actually use this equation here and solve for x. So in order to solve, I'm going to divide everything by 3. So I get x equals 5. So remember, for a system, we're looking for a solution. Our solution is going to be some x comma y. So we have our x value, but we still got to find the y value. So in order to find the y value, you're going to take your x value and you're going to plug it into either your top equation or your bottom equation. It doesn't matter which one, you're going to get the same value, or you should get the same value either way. But I would recommend choosing the equation that has these smaller numbers, just to make the math a little bit easier. But it's up to you. So I'm actually going to choose the second equation. So I'm going to choose negative 3x plus 4y equals 1. And I want to plug in the x value that I just found. So negative 3 parentheses 5 plus 4y equals 1. All right, so negative 3 times 5 gives me negative 15 plus 4y equals 1. And now it's just like an equation from unit 1. We're just solving equations. So for this step, I'm going to add 15. So we're going to have 4y equals 16. Then I want to divide both sides by 4. So we get a y value of 4. So now you want to rewrite your solution as a coordinate. So remember, you have to write it in a very specific order. It has to be x comma y. So in this case, it would be 5 comma 4. So just know, if you write 4 comma 5, your answer is still technically incorrect. You have to write it in a very specific order. All right, now looking at the second one here. So now we have 5x plus 2y equals 4, negative 5x minus 6y equals 8. So first, make sure everything is in standard form and vertically aligned. So ax plus by equals c, ax plus by equals c. And then just like before, your x values, they're lined up. Y values, lined up. And c values, lined up. Now you want to look to see if where you're going to have your zero pair. You want to see where your inverse values are. So if I look at my x values, we have 5 and negative 5. Well, right there. If I add those together, I get 0. So there's my zero pair. So I'm going to add these equations together. All right, so 5 plus negative 5x gives you 0x plus 2 plus negative 6, nope, gives you negative 4y, so minus 4y, equals 4 plus 8, which gives you 12. All right, so anything times 0 just gives you 0, so I don't need that x value anymore. So I'm going to have negative 4y equals 12. Now I want to solve for y. So I'm going to divide by negative 4. So y is going to equal negative 3. So just a word of caution for everyone here. Please know that your first variable that you solve for, let's say you forgot the negative and you left it positive. The rest of your problem is going to be a wreck. It's probably going to be wrong, unfortunately. So these are what I call the domino problems. You mess up at the very beginning, the rest of it's going to fall with it. So you have to be very careful. All right, so now I found my y value. So I want to find the x value. So once again, pick an equation to plug it in. It doesn't matter which one. I'm going to use the top equation just to not deal with negatives. So 5x plus 2y equals 4. I'm plugging in for y. So 5x plus 2 parentheses negative 3 equals 4. All right, so I have 5x minus 6 equals 4. Add 6 on both sides. So 5x equals 10. Then divide both sides by 5. So you get the next value of 2. All right, so now you just need to write your coordinate. So your coordinate here, 2 comma negative 3. All right, so you might be asking yourself, well, maybe not, what if one of these variables doesn't eliminate? So if your equations or your system doesn't already have a zero pair in place, there's a few different strategies that you can try. So you can rearrange it to align correctly, in which case you may get a zero pair just from rearranging. You may need to change the signs. So if you want to multiply one or both of your equations by a value, you can. So whether you multiply by -1 or by a factor, whether it be another number, you can. So there's a lot of different manipulations that you can do in order to get a zero pair. All right, so we're going to just look at this first one. So if you notice your top equation here, we have ax plus by equals c. Top equation, we're in standard form, so we are good to go. But if you look at the bottom equation here, we are not in standard form. So I'm going to rearrange. So remember, for standard form, you want your x's and y's to be on the same side. So I have my 4y equals 3x plus 14. So in order to put this in standard form, what I'm going to do is I'm going to subtract 3x on both sides. So I'm going to have negative 3x plus 4y equals 14. So I'm going to look at this equation and my top equation and kind of compare them. So if you notice, your x values, they're not inverses, so that's not going to do me any good. But if you look at your y values, positive 4y and negative 4y, those are inverses of each other. So I'm actually going to leave my equations exactly how they are now. So what I'm going to do is I want to rewrite both of those equations so that I can do elimination. So I'm going to start off with 8x minus 4y equals negative 4. And then I'm going to bring over this equation that I just found. So negative 3x plus 4y equals 14. So now I want to do my elimination. So everything's lined up, everything's in standard form, so I'm good to go. So when I look at my x values, 8 plus a negative 3 gives me a positive 5x. My y values, they zero out. So negative 4y, positive 4y, they're gone. And then negative 4 plus 14, which gives you positive 10. So remember, anything times 0 is just 0. So you have 5x equals 10. Now I'm going to divide both sides by 5. So x is equal to 2. All right, so once again, we found the x value. Now we still got to find the y value. So once again, it doesn't matter which equation you plug it into. Now here's the thing. When you're looking at equations to plug in the variable, you can use either of the original two equations, or you could even use one of the manipulated equations. It doesn't matter which equation you plug it into. So just because the second equation here is already almost solved for y, I'm just going to use that one. So I'm going to have 4y equals 3x plus 14. So I'm solving, nope, not solving. I'm subbing in for my x value. So I'm going to have 4y equals 3 parentheses 2 plus 14. All right, so I'm going to have 4y equals 6 plus 14. So 6 plus 14 gives me 20. And now I just need to divide by 4, which means my y value is equal to 5. So my coordinate here, I'm going to have 2, 5. So there may be an extra step at the very beginning that you may need to do, but depending on the setup, depending on the numbers, it may be necessary. All right, hello. So looking at this next one. So number 2. So we have 2x plus 5y equals 12 and 4x plus 6 equals 5y. All right, so if you notice, your top equation is in standard form, but your second equation is not. So what I'm going to do is I actually want to move over my 5y, because if you notice, we have a positive 5y here, but if I subtract over this 5y to the other side, it would become negative. So that's what I'm going to start off with. So I'm going to subtract 5y on both sides so I can make it negative and put it in standard form. So I have 4x minus 5y plus 6 equals 0. But now to officially put it in standard form, I'm going to go ahead and subtract 6 as well. So I'm going to have 4x minus 5y. That is a terrible 5. 5y equals negative 6. All right, so there's that equation. Now I want to take my top equation and I'm going to rewrite it underneath right here. So 2x plus 5y equals 12. So this is the system that I really am going to be looking at right here. So everything is vertically aligned. So my 5 values, or my y values, those are inverses of each other. So that's going to be my 0 pair. So I'm good to just start adding values together. So 4 plus 2x, or 4x plus 2x gives you 6x. My y's would 0 out, create a 0 pair. And then I'm going to have negative 6 plus 12, which gives me positive 6. So anything times 0 gives me 0. So I have 6x equals 6. Now I want to divide everything by 6. So I'm going to have x equals 1. All right, so we have our x value. Now you need to solve for your y value. So I'll use the second equation. 4x plus 6 equals 5y. All right, so I'm plugging in 1 for my x value. So 4 times 1 plus 6 equals 5y. So I'm going to have 4 plus 6 equals 5y. So 4 plus 6 gives me 10 equals 5y. And now I'm going to divide both sides by 5. So I get a y value of 2. So your coordinate here is going to be 1, 2. Hello. There we go. All right. So on to the next page. So this next page is really just going to be using the multiplication method. So where you have to multiply either by -1 or multiply by a factor, because your systems are not always going to be set up to just have a 0 pair. So if you look at this top equation, number 1, we have negative 5x minus y equals -4, 6x minus y equals 7. So if you notice, everything is in standard form, so we're good to go there. However, there are no 0 pairs anywhere. The closest thing we have are these two negative y's, but they need to be opposite signs in order to 0 out. So what that means is I want to multiply one of my equations by -1. I just want to flip the signs. So it doesn't matter which equation you multiply by -1, but if you look at this top equation, it's nothing but negatives, just like my life. Just kidding. So what I'm going to do is multiply this entire equation here by -1. So it's going to be 5x plus y equals +4. There we go. All right, so now if you look, our x's are aligned, but they're not 0 pairs. Y's are aligned, those are 0 pairs. And then our c values are also aligned. So when I add, so 6x plus 5x gives me 11x plus 0y equals 7 plus 4, which is 11. Anything times 0 just gives you 0. So we're just going to have 11x equals 11. And then divide everything by 11, which gives you an x value of 1. All right, so now I found my x value. Now I need to find the y value. So I'm actually going to plug it into this manipulated equation down here. just because they're positives and the x value is pretty straightforward. So I'm going to start with 5x plus y equals 4. Now down here, I'm plugging in my x value. So I have 5 parentheses 1 plus y equals 4. So 5 times 1 gives you 5 plus y equals 4. So now I'm going to subtract 5 on both sides. So I'm going to have y equals -1. So my coordinate here, 1, comma, -1. Perfect. All right, moving on to number 2. All right, so we have x plus 3y equals 1, -5x plus 4y equals -24. So if you look, everything's in standard form, so we don't have to do any rearranging. However, there are no zero pairs. So what that means is we're going to have to multiply one or both of my equations by a factor. But if you look, I have a coefficient of 1. I can easily multiply and make those a zero pair. So what that means is they're already opposite signs. You need to look for opposite signs. If you see the same signs, it's not going to be ideal. So what I'm going to do is, because I have a positive 1 in the top equation for my x values, I'm actually going to multiply this equation here by a positive 5. So when I multiply that top equation by 5, I'm going to have 5x plus 15y, and that's going to equal 5. So now once I multiply by 5, now right here, my x values, now I have a zero pair. Now I can do elimination. So to start off, -5x plus 5x gives you 0x. And then 4y plus 15y gives you 19y. The -24 plus 5 gives you -19. So once again, anything times 0 just gives you 0. So we have 19y equals -19. So now I want to divide both sides by 19. So I get a y value of -1. So now we need to solve for the x value. So I'm going to take that y value that I just found and plug it in to one of my equations. Doesn't matter which one, but considering I want small numbers, I'm going to use this top equation. So I'm going to use x plus 3y equals 1. So I have x plus 3 parentheses -1 equals 1. So 3 times -1 is going to be -3. And now I need to add 3 on both sides. So x equals 4. All right, so that means our coordinate here is going to be 4, comma, -1. All right, now looking at number 3. All right, so if you notice, we don't have any zero pairs. However, they are lined up in standard form. So they vertically align. However, if you notice, if I want to eliminate the x values, I would have to multiply this bottom equation by 3. Or if I want to eliminate the y values, I could multiply the bottom equation by 2. So it really doesn't matter which one you want to eliminate, whether you want to eliminate the x's or y's. Just make it as easy as possible for yourself. So just because the y values are actually smaller, I'm actually going to eliminate the y's, which means I need to make this coefficient right here, I need to make that a positive 2. So it's already positive, so I don't have to change the signs. So I'm just going to multiply this equation by 2. All right, so I'm going to have -4x plus 2y equals -10. All right, then I'm going to bring down this equation over here. I'm not going to manipulate it in any way. I just want to rewrite it. So 6x minus 2y equals 2. So now my y values are inverses and they make a 0 pair. So now I can do elimination. So I'm going to do negative 4x plus 6x, which is going to give me 2x plus 0y. Then I get negative 8 for my c values. So anything times 0 gives you 0. So we're going to have 2x equals negative 8. So now I'm going to divide by 2 on both sides. So I have an x value of negative 4. So now I need to find the y value. So I'm going to plug it into one of my equations. It doesn't matter which one. So I'll use this bottom equation. So I'm going to use negative 2x plus y equals negative 5. So what I'm going to do next, plug in that x value. So negative 2 parentheses negative 4 plus y equals negative 5. So negative 2 times negative 4 is going to give you a positive 8 plus y equals negative 5. So now we need to subtract 8 on both sides. So I'm going to have y equals negative 5 minus 8, which gives me negative 13. So my coordinate here, so I'm going to have negative 4 parentheses negative 13. All right, now for number 4. So right off the bat, I can see my top equation is good to go. It's already in standard form, but my bottom equation is not in standard form. So I'm going to start by rearranging. So I'm going to subtract 5x on both sides. So I'm going to have negative 5x plus 9y equals 5. And now just to compare the equations, I just want to bring down, perfect. Just want to bring down my other equation. So 3x minus 7y equals 5. Now, if you notice, we don't have any 0 pairs, but see how we have opposite signs? That's at least a good sign for us. So we have the x's that are opposite signs and the y's that are opposite signs. So in this case, I can't just multiply a value, like I can't multiply 3 times something and get 5, at least not by a whole number. So what that means is I'm actually going to have to multiply both of my equations by something. So just because my x values have smaller numbers, I'm actually going to eliminate the x's. You can eliminate the y's, but that means you'd have to multiply by even bigger numbers, which may just make it more complicated. So what I'm going to do is this top equation here, because the other number is 3, I'm going to multiply this entire equation here by 3. And the bottom equation, I'm going to multiply by the other value, which is 5. So how I'm going to set this up. All right, so you can set this up many different ways. So this top equation, multiply by 3. Bottom equation, multiply by 5. So I'm getting those values from the other equation. That's terrible. There we go. Just so you can see like where I'm getting the 3 and 5 from. So when I multiply, so your top equation is now going to be negative 15x plus 27y equals 15. And then my bottom equation, I'm multiplying by 5, which means I'm going to have 15x minus 35y. That's going to equal 25. All right, so now I can do elimination. Because if you look, now my x values are inverse values. So when I eliminate, I'm going to have 0x minus 8y equals 40. Yeah, just making sure I can do math. All right, so now I'm going to have negative 8y equals 40. Now I want to divide by a negative 8. So when I divide by a negative 8, that's going to give me negative 5. So now that I found the y value, now I got to plug in and find the x value. So that was all just to find one value. So once again, it doesn't matter which equation you use, but I'm just going to use this top equation up here. So 3x minus 7y equals 5. All right, so I'm going to plug in negative 5 for my y value. So 3x minus 7 times negative 5 equals 5. So I'm going to have 3x plus 35 equals 5. So now I'm going to subtract 35 on both sides. So I'm going to have 3x equals negative 30. Oh my god, that line is crooked. There we go. All right, and now I want to divide by 3, which gives me an x value of negative 10. All right, so my coordinate here, I'm going to have negative 10, comma, negative 5. Oh my god, there. All right, so I will say, as you can probably see, these are going to be your more challenging elimination problems just because you have to multiply both of your equations by a value. All right, moving on. Number 5. All right, so once again, no zero pairs, everything's in standard form. I can't multiply 3 times something and get 4, so that's not going to be very ideal. I can't do 2 times something and get 5, so that's not going to be ideal. So that means we're going to have to multiply both of our equations again. However, if you're looking to see which one would be better, the x's or y's, well, the x values already have opposite signs. So I wouldn't have to multiply by a negative, but if I do the y values, I'd also have to multiply by a negative. So, and the numbers would be bigger. So that one's probably not going to be ideal. So what that tells me is I'm going to go and eliminate the x. So I pretty much want to swap the values. So because I have a 3 down here, I want to multiply this entire equation by 3. Because I have a 4 up here, I want to multiply this equation by 4. All right, so what I'm going to do, top equation, I'm going to multiply it by 3. So when I multiply by 3, that's going to give me 12x plus 15y, 7105. Yes. All right, now my bottom equation, I'm going to multiply by 4. So I'm going to have negative 12x plus 8y equals negative 36. Let's see if I can do math. It's fine, I only teach math. Mental math is hard. All right, so 12x minus 12x gives you 0x, so those 0 out. 15y plus 8y gives you 23y. And then 105 minus 36 gives you 69. So anything times 0, 0's out. So 23y equals 69. And then I'm going to divide by 23. So y is going to be 3. All right, so now I want to plug in and I want to find out what my x value is going to be. So I'm going to use the second equation here. So negative 3x plus 2y equals negative 9. So I'm going to plug in for the y value. So negative 3x plus 2 parentheses 3 equals negative 9. So negative 3x plus 6 equals negative 9. So I'm going to subtract 6 on both sides. So that gives me negative 3x equals negative 15. Then I want to divide both sides by negative 3, which means x equals 5. So we're going to have 5, 3. Boom. All right. Last but not least. So notice how both of our equations are already in standard form. So no rearranging has to be done. So I would actually say pause here and try this one on your own. Or if not, no worries. So looking at my x values here, we have a coefficient of 1 and negative 5. So they're opposite signs. I could easily multiply that top equation by 5 to make those 0 pair. However, if I look at the y values, we have positive 3, positive 4. I'd have to multiply the top equation by 4, bottom equation by 3. I'd rather just multiply one equation. So the y's you can eliminate, it's just not going to be as easy. So I'm just going to multiply my top equation. So I'm going to multiply by 5. So when I multiply by 5, we're going to get 5x plus 15y equals 5. This is literally the same thing as the very first one, or as number 2. Just kidding. Ignore this problem. I actually need to do a special case anyways. So for special cases, we actually didn't do one yet. So let's do x plus 2y equals 5. Let's do negative 2x minus 4y is negative 10. All right, so let's just kind of go over this problem instead. Kind of just making this one up as I go. I'm hoping this works. Thoughts and prayers. What am I doing? All right, so if you notice, everything's in standard form. However, there's no 0 pairs. So if you notice, our x values here, they're already opposite signs. Y values are already opposite signs. So it really doesn't matter which one I eliminate. So let's just multiply the top equation by negative 2. So I'm going to get not negative 2. Just kidding. What am I doing? This is what happens when I improvise. Multiply the top equation by positive 2. English is hard. Math is hard. Everything is difficult. Everything's fine. No. There. So multiply the top equation by 2. So we're going to get 2x plus 4y equals positive 10. So our top equation here is done, so we can kind of ignore that one. So notice what's going to happen when I add everything up. Negative 2 plus 2 gives you 0x. Negative 4y plus 4y gives you 0y. And then negative 10 plus 10 gives you 0. So we're just going to have 0 equals 0. So because 0 equals 0, that's actually a true statement, which means this is going to be IMS. It's going to be infinitely many solutions, or all real numbers, fancy art. Perfect. We're doing great. Anyways, so, however, let's say, hello, no. Let's say I take the same problem, and let's say instead of it being a 5, let's say I make it a 4. literally just any number, except for 5. So if I follow the same idea, I try to eliminate, multiply by positive 2. Come on, there we go. All right, so if I multiply by 2, so I'm going to get 2x plus 4y equals 8. So when I eliminate here, that equation's gone. You get 0x plus 0y equals -2, which means you're going to get 0 equals -2, which means that's actually false, because 0 does not equal -2. And because it's false, that means we're going to have no solution.